We are down to our two last videos for the second grading period. This first video will focus on graphing a quadratic function, and the next video, the last one, which will be presented later, will be the video for the determination of the analysis and important essential details of the quadratic functions. So I'm going to share to you right now the four four quadratic functions we are going to graph. So I have already presented here some important needed items such as the rectangular coordinate plane for us to have an easier graphing later. So this task is only focused first on the graphing portion. No need for more analysis. First, determine the vertex, and then use that vertex to determine the table of values, and then we slowly graph the following quadratic functions. So we have four quadratic functions here, so please bear with me. It may take a longer period of time, but anyway, we are designing this video so that you could actually see how it's done properly. So the first one is for number one, f of x is equal to negative 2x squared. For this given function, the first is to find the vertex. We all know that the given here has coefficients negative 2, b has none, and 0 as well. Okay, so to get the vertex, we need to solve. I may need to push this down a little bit lower. Okay, so need to get the vertex first. And we do have the formula for the vertex. X is equal to negative b over 2a. And whatever will be the value for this, we can simply substitute it in the given to solve for its partner value for f of x or y coordinate. So we have this, and then we have this value. We have negative 0 over 2 times 2. So regardless of whether what is the result in the denominator, the numerator already tells us that the result for the x coordinate should be 0. This is the x coordinate of our vertex, 0. As for the y, or the f of x coordinate, simply substitute this to the given. So substitute this to the given, and 0 squared is still 0 times negative 2. So we have 0. That's the value for our vertex. Our vertex, it's at the origin, 0, 0. The next task is to make the table of values. And why is it that the vertex is very important? When you make your table of values, of course, we need to come up with a graph. The graph is expected to be a parabola. If in linear functions or linear equations in your grade 8, you were able to actually just need two different points and connect it to form a line because 2 points determine a line. Here, our graph is a parabola. To properly see the parabola, we need at least 5 points with the vertex located at the middle. Okay? As to why? Because we all know that vertex is a turning point. It is where the graph changes direction from either increasing to decreasing or decreasing to increasing. So graph of for us to see the proper parabola, we need to have the vertex in the middle, and then later on the values for extend the values on both sides of the x-axis. To do that, we need to include here 1, we need to include here negative 1, here as well for 2, and then here negative 2. Let's just use integers for us to have an easier determination of the points. So we have here 1, 2, negative 1, and negative 2. So substitute all of these values to the given function. In case we're in the vertex, is say for example, the vertex is 5 and then 2. Our vertex should be placed in the middle, 5 and 2. And we will not be using 1, negative 1, 2, and negative 2. We'll be using the values 2 steps to above 5 and 2 steps below 5. Okay, that's just an illustration. Let's substitute. 1 here. 1 squared is 1. 1 times negative 2, so you do have negative 2. As for 2, 2 squared is actually 4 times negative 2 is we have negative 8. On the other side, negative 1, the square of negative 1 is positive 1 times negative 2, it should be negative 2. Please be careful with the signs. If your answer here is a positive 2, you will not be making a parabola here. The hint in the table of values, the hint that you need to remember for you to know whether your table of values is correct or not is simply this. Look at the values one step away from the vertex in the f of x row, negative 2, negative 2. They must have the same value for us to see a parabola. As for here, negative 8, so this should be negative 8. But let's try. The square of negative 2 is positive 4 times negative 2, we do have negative 8. As you can see, the value for this two steps away from the vertex in f of x row is just same as the to the right. So we have these values, and then we need to plot this here. Since we do have negative 8, and I believe my graph is just until 4, if I'm going to use here by 1, I'm going to use this by 2. So instead of having it 1, 2, 3, 4, I'll be making it 2, 4, 6, and then 8. This is the x-axis. This is the f of x, or also known as the y-axis. Okay, so that I will be plotting here all points. I'll start with the vertex. I will use red, 0, 0. I will use green for the rest of the points just to differentiate what where is the vertex. Then I will have 1, 1, and then negative 2. I have here this point here. Again, I'm using per scale of 2. And then I have negative 1 here in the middle because I'm using per scale of 2. And you have negative 2. Why do I am using scale of 2? Because I need to see 8. I don't have any 8 here. So negative as positive 2, we have here 8. And negative 2, I also have here 8. Sorry for that. It should be closer here. And then I'm going to connect all the points here. Okay. Uh, yeah. I should connect all the points. And I will be making here an arrowhead. The arrowhead is telling us that there is actually the parabola actually extends towards more values, so that it means it still continues to go on and on. This is the somewhat, if my graph should be straight, but it's not straight for at this point of time. So I'm going to have it like this. Okay, negative 4. Okay, so this is the graph for number 1. Okay, so let us apply the same processes in graphing item number 2. So let's start by determining the vertex. Here, the coefficients are 1. We don't have b coefficient. And then our c is negative 4. For our vertex, we could locate the x coordinate using the formula. Negative 0 over 2 times 2a, which is actually 2 times 1. However, regardless of what the value of this, it will still be equal to 0. So our vertex is at 0, and then substitute the solved value for x here, the given equation, to determine the y coordinate, or the value for the f of x. If x here is 0, 0 squared, that's 0 minus 4. So we have here negative 4. Upon determining the vertex, similar to number 1, we can now, sorry, we can now create our table of values. Again, we are going to need 5, at least 5 points where the vertex is located here, 0, and then negative 4. And we choose the values of x by one step above and below 0, which are 1 and then 2. Here, negative 1, negative 2. Do not make a conclusion like these are all the, there is always this, these are the values that you should try to make your graph. Again, it depends now on what is your vertex. Luckily, for number 1 and number 2, we have 0 here for x values. That's why we have the same group of values for the x in our table. Let's try. Starting with 1. 1 squared is 1 minus 4. We have negative 3. For 2, 2 squared is 0. I mean, 2 squared is 4 minus 4, which is 0. Similar to number 1, this should be negative 3 and this should be 0 for us to see a correct parabola. If we're going to substitute here negative 1, the square of negative 1 is 1 minus 4, that's negative 3. As for negative 2, the square of it is positive 4 minus 4, you will have here 0. So since the values here per one step are just the same, we are rest assured that it's actually the correct table of values. And then, again, this is our x-axis. We have here f of x-axis. Unlike number 1, wherein we reach until a value of negative 8, here we have negative 4 only. So let us just use the graph here in terms of 1 unit. Earlier, it was in terms of 2 units. Now let's just use 1 unit. That means this is 1, 2, 3, and then 4, and the other side as well as the negative values. So let's plot here first the vertex 0, negative 4. I'm going to use the colored red circle so to denote vertex. And then next will be the other points 1 and negative 3, and then negative 1 and then negative 3. Next would be 2 at 0 and then negative 2 at 0. So connecting all of these values here, hopefully we can make a correct parabola. All right, that's better. It may not be very open, but it might be as steep as this. So this is actually our graph of the given quadratic function x squared minus 4. And then just to find to what you call that, polish, you could just use here probably. Okay. So this is the turning point, the vertex, and these are our parabola. It opens upward. In comparison to number 1, we could also create this analysis if you want. In comparison to number 1, our graph in number 1 opens downward. Our graph in number 2 opens upward. We could also actually just what do you call that? Analyze using the leading coefficients. The leading coefficient for number 1 is a negative value. The leading coefficient of number 2 is a positive valued one. If it's a positive value, the parabola should open upwards. If the leading coefficient is actually a negative value, it should be opening downwards. That is an um, additional analysis that you could make. Let's proceed with number 3 here. In number 3, again, we just need to start with vertex. However, luckily for number 3, it is already in a vertex form. The vertex form of quadratic function, if you can still remember, is a, and then you have h minus, sorry, that's x minus h, square of it, and then you have here plus k. And your vertex is determined by the value of h and the value of k. We still can still use here the formula to determine the vertex for number 3, which is similar to what happened in number 1 and number 2. But of course, we just use here the concept of the vertex form. So in short, x plus 1 can actually be written as x minus negative 1. That's and then minus, or you could also express it as plus negative 4. So our vertex is as h and at k. So h is actually our vertex, h which is negative 1, and k which is negative 4. If you would like to try again, you could actually, since we could determine here the A, B, and C coefficients. You may break this, expand this, simplify, and then determine later on the A, B, and C coefficients. But definitely they will just return to this given value. If you would like to try, you may do so. Okay, now that we have this vertex, again, make your table of values over f of x. And then, oops, sorry. Then at least 5 values. You will have here your negative 1 and negative 4. So you can see, since the centermost point will be your vertex, you will not be using the same values as you used earlier. Rather, you will be using 0, 1, -2, and then -3. So it's not all the time that you will use these values here. It depends now on your vertex. So let's substitute it here. 0 plus 1 is 1. Square of it is 1 minus 4. So you have -3. Okay. Next would be 1. 1 plus 1 is 2. The square of it is 4. Minus 4, you will have here is 0. For the other side, -2 plus 1 is -1. The square of it is +1. Minus 4, you have -3. And then -3 plus 1 is -2. The square of it is 4. Minus 4, you will have here 0. Okay? So plotting all these values, still we have here 4. So let's just use this as in terms of 1 unit. So our vertex now is at -1 and 4. -1 and 4. Okay. And then you will have here the values 0 and -3 and 1 at 0. And then you will have -2, -3, and then -3 and 0. So your graph should look like this. It should actually form a parabola. Pardon if my graph is not that accurate. Okay. So it will somehow look like this. It's not that very accurate, but it will look like this. Right? So the vertex is still here. Some of you might have analyzed something. Wherein in number 2 and number 3, you have the same values for f of x here, 0, -3, -4, -3, and 0, as well as here, but of different partner x coordinates. As you can see, you still have almost the same graph, but it moved one way to the left, 1 point to the left, because the value for the x coordinate here is 0, and you have your -1 here. So it still opens upward because your a coefficient, leading coefficient here, which is actually found here because of this, is positive value. Then finally, let's proceed with number 4. So since this is in a form of what you call standard form of quadratic expression, or a form wherein leading a decreasing degree of a term, so let's try to determine it using the coefficients. A is 1, B is 4, and C is -1. Okay. And then you can actually come up here with a vertex. X coordinate is -b, so -4 over 2 times 1, which will be resulting to a -2 value. So -2, that's your x coordinate of your vertex. Simply substitute here to the given, and as well as here. So we will have, so let's not, and then here. So we could actually separate the graph here. So -2 squared is positive 4. Right? So you have positive, let me write it here, positive 4. So -2 squared, so -2 squared is positive 4. And then -2 times positive 4 is actually -8. And we have here -1. So the value here is actually at, that's 4 minus 8 is -4, -1 is partnered with -5. Okay? Again, it's -2, negative. Let's try to check it again. -2 squared is positive 4. 4 times -2 is -8, and then we have -1. So the vertex here is positive, I mean -5. Okay, so let's try to make our table of values, x, and then you have your f of x. So you have here -2 vertex in the middle, -2, and -5. So let's try to add values here. Again, it will not use these sets of values of x, nor what are used here, but if we actually use -1, then you have 0, and then you have here a -3 and -4. Substitute them slowly. For negative 1 squared is positive 1. And negative 1 times positive 4 is minus 4, and you have minus 1. So 1 minus 1 is 0. We are left with negative 4. For 0, 0 squared is 0, plus 4 times 0, which is also 0. So we are left with minus 1. The pattern should return here negative 4 and negative 1. It should return. Let's try. Negative 3 squared is positive 9. 4 times negative 3 is minus 12. And then we have here minus 9. So 9 minus 12 is negative 3, minus 1, negative 4. As for negative 4 squared is positive 16. The negative 4 plus, negative 4 times positive 4 is minus 16. Then you have minus 1. So 16 minus 16 is 0, and you have here minus 1. So we could actually come up here with the correct values and then plot them in the real number line. Since it's 5, let me just include here probably one more scale so that it will actually be 5. All right, that's it. And then you will have here 2 and negative 2 and negative 5. Sorry for that. That will increase the size. That's all. And then negative 1 and negative 4. Let's use the color green. And negative 3 and negative 4. And then you have here 0 at negative 1. And then you have here the values, sorry, the values for um, negative 4 and negative 1. So your graph, rather, should look like this. Okay. Okay. So this is the graph of the number 4. So again, in graphing quadratic functions, you follow the simple steps. Number 1, determine the vertex here. And then you make your table of values based on the vertex placed at the center, which needs actually at least 5 points. When you say at least, you could increase it to 7 if you want, but 5 could actually let you show a parabola. And then you graph them. Okay. These are for numbers 1, 2, 3, and 4. Okay. The next video will still use these quadratic functions, but we are now going to analyze the graph to determine the following. Number 1, we are going to determine the intercepts. Number 2, the line or the axis of symmetry. Number 3, the domain and the range. We are going to determine them using the graph that we have made in this video. So please stay tuned for the last video of the second grading later. Goodbye.